Now that we've talked about how data moves across the network, we're ready for two models you will hear again and again in networking: the OSI model and the TCP IP model. Now, when people first hear the word model, it can sound intimidating, but a model is really just a simplified way to understand something complex. That's exactly what these models do. They help us break networking into smaller pieces so it becomes easier to understand what is happening, where it is happening, and what each part of the network is supposed to do. You might be wondering, why not just learn the protocols and move on? Because without a model, networking can feel like a pile of disconnected terms. You hear things like layer 2, layer 3, frames, packets, switching, routing, and ports, and it can all start to feel confusing. Models give us a mental map. They help us organize what each part of networking is doing. So instead of memorizing random vocabulary, you begin to see how the pieces fit together. That is why network models are so important. They give you a way to think clearly about how networks work. Let's start with the OSI model. The OSI model is the more detailed of the two. It breaks networking into 7 layers. From bottom to top, those layers are physical, data link, network, transport, session, presentation, application. That may sound like a lot at first, but don't worry. At this stage, you do not need to obsess over every tiny detail. What matters most is understanding that the OSI model gives us a structured way to picture how data moves from one device to another through different stages. Let's make the lower layer simple. The physical layer is the actual connection side of networking. Think cables, signals, and the physical path the data travels on. The data link layer is where data is carried in frames. This is also the layer associated with switches. The network layer is where data is carried in packets. This is the layer associated with IP addresses and routers. That is why people often say things like switching is layer 2, routing is layer 3. Those phrases come directly from the model. Now let's look at the upper part of the OSI model in a beginner friendly way. The transport layer helps move data between applications. The session layer is about managing conversations between systems. The presentation layer helps make sure data is in a usable format. And the application layer is the layer closest to what the user interacts with. So, in simple terms, the lower layers are more about moving data through the network, and the upper layers are more about helping applications use that data meaningfully. You do not have to master every detail right now. At this level, the goal is simply to understand that the OSI model gives us a full, detailed breakdown of network communication. Now let's compare that to the TCP IP model. The TCP IP model is simpler. Instead of 7 layers, it has four: network interface, internet, transport, application. So right away, you can see the big difference. The OSI model is more detailed. The TCP IP model is more streamlined. Here's the easiest way to think about the relationship between the two models. The TCP IP model combines some of the OSI layers together. For example, the TCP IP application layer covers work that in the OSI model is divided into application, presentation, and session layers. The TCP IP internet layer lines up with the OSI network layer. The TCP IP transport layer lines up pretty closely to the OSI transport layer. And the TCP IP network interface layer covers what the OSI model splits into the data link and physical layers. So the two models are not enemies. They're just two different ways of organizing the same general networking process. One thing that can confuse beginners is this: the mapping between the OSI model and real world protocols is not always perfectly neat. In other words, not every real protocol fits into one little box in a perfectly clean way. Sometimes functions overlap. Sometimes a protocol handles more than one kind of job. So the models are helpful, but they are still models. They are tools for understanding. They're not meant to trap you into thinking every real world networking process will look perfectly separated in everyday practice. For beginners, here is the best mindset: use the OSI model to understand networking in a more detailed step by step way. Use the TCP/IP model to understand the practical, simpler layer structure used to describe the IP protocol suite. So if the OSI model feels like a detailed diagram, the TCP/IP model feels like a more compact version. Both matter, both help, and both give you language you will hear throughout networking study and troubleshooting. This lesson matters because these models give you a framework for everything that comes next. When someone says a switch works at layer 2, you will know where that comes from. When someone says a router works at layer 3, you will know why. When you hear about frames, packets, transport, applications, and protocols, you will have a mental map for placing those ideas in the right part of the process. That makes later lessons easier. It also makes troubleshooting easier because you can start asking better questions about where a communication problem is happening. So let's wrap this up. The OSI model is the more detailed model with 7 layers: physical, data link, network, transport, session, presentation, and application. The TCP IP model is the simpler model with 4 layers: network interface, internet, transport, and application. The OSI model helps you study networking in a detailed way. The TCP IP model helps you understand the practical structure behind the IP protocol suite. And most importantly, both models help make networking easier to understand. In the next lesson, we'll keep building on this foundation.